Greetings everyone, my name is Jad Farazallah and today I'll be talking about 3D printing in ceramics. Firstly, we need to understand what is 3D printing. 3D printing, or what is known as additive manufacturing, is a process of making three-dimensional solid objects from a digital file. We usually use a CAD model for that. Now, the creation of a 3D printed object is achieved using additive processes. What we mean by that is that the printer, or the 3D printer, basically creates the object by adding successive layers of the material that we're using above each other. These layers are usually thin and sliced horizontally above each other.
3D printers have been used to make all kinds of amazing objects, like prosthetic limbs for children, actual biological tissue, working bicycles, and they've even been used by astronauts to print objects in space. So for all you Harry Potter fans out there, we're now going to show you how you can create a Harry Potter set of glasses for yourself on a 3D printer using plastic. The first step in the series is to take the digital file of this object and examine it for errors. Once you have a correct file, we can move to the next stage, which is to actually decide the print settings for this object, the speed of the print nozzle, the temperature that you will melt the plastic to before printing, and many other similar details. Once you've worked out this set of settings, you feed this into the computer and then hit print. During printing, the 3D printer will tell you how much of your print is complete by giving you a percentage and estimating how much time is left to complete the print.
Now we really should understand how do 3D printers work. This video might be very beneficial with the description, but let's say a 3D printer essentially works by extruding the molten material through a tiny nozzle. Then this tiny nozzle basically moves with high precision under the computer control, following the CAD design that we've already inserted into the computer system. It basically prints one layer, waits for it to dry, and then prints the next layer on top of it. The materials that can be used in 3D printing are of a huge and wide range. We can use plastic, silver, titanium, steel, wax, photopolymers, polycarbonate. Many people actually use chocolate for that, and in the presentation that we're discussing right now, ceramics. Now we need to understand why is 3D printing important. 3D printing is considered to be of high importance due to its production speed, easy accessibility, better quality, cost effectiveness, and the creative designs and customization freedom. What I believe to be the most important advantage of 3D printing is that a person can basically a person can create anything from his or her imagination. The picture that we're seeing on the right here is a very good example of that. The picture shows a prosthetic limb made by 3D printing. As we know, many people around the world are in need of such limbs, and 3D printing made it easier for these people to achieve or to get these body parts in a very cheaper way.
In order to explain the move from prototypes to actual objects, which was assisted by the AHRC funding, it's best to talk about physical materials, real materials. We can now actually print in a real ceramic material that has the same aesthetic and quality as other ceramics do, whereas previously for prototypes you're printing in plastic or plaster materials, which don't have the same surface feel or quality or tactility. so that it allows people to be able to print an object with just that right look, feel and aesthetic that you wouldn't get in any other way.
Now in this short video here, we're going to see Professor Stephen Hoskins, the director of the Center of Fine Print Research in the University of West England, talk a bit about the introduction of 3D printing of ceramics. Before we get to the part about 3D printing of ceramics, we firstly need to understand why ceramics, why use these materials. Now, as we discussed before in the lectures with Dr. Abdullah, ceramics are inorganic materials that have high strength and high melting points due to their strong ionic and covalent bondings. Mostly they are electrical insulators due to the absence of free electrons in the bondings. They are heat insulators due to the pores, and most of them are corrosion resistant. Now, due to these various excellent properties, ceramics are used in a wide range of applications from chemical industries, machinery, electronics, aerospace, and biomedical engineering.
To describe the process of how it's made, our particular process uses a powder. There are printers that deposit plastics, there are printers that will print in metal, and there are printers that build up in various ways using photopolymeric materials. But to put it simply, we have a bin, a box of powder, and if you imagine that box being quite empty with a plate at the top of the box, you have a thin layer of ceramic powder. If you're printing a cup or a plate, you print a small ring at the very bottom, one thin layer at the bottom of that cup or plate, and then it drops down one step and we push some more powder over the top. Then it will drop down another step and push more powder over the top, and you print one single layer at a time and slowly build your object up in thin layers, which is why you can print incredibly complex shapes, because they're just supported all the way around by powder as this shape keeps dropping down. Finally, when the whole thing's printed, it's left to dry in the bin of powder, and then after an hour or so, you lift the whole plate out and dust all the powder off from the object, and in the middle of there, you have an object. That object needs drying further, so we put it in an oven to make sure it's really quite solid, before we then put it into the kiln and fire it. That's known as a biscuit firing, the first firing. And at this stage, that's where it becomes same as a normal ceramic process, because you would have a biscuit firing in ceramics. So we biscuit fire it to a temperature and then take it out of there. You can then glaze the object and refire at a higher temperature for the glaze to go over the ceramic object. And then you can have a third firing if you decorate, where you would refire to the decoration on top. But you will always have at least two firings.
This video here can actually be beneficial to show us the process of the 3D printing in ceramics. To summarize the video in some words, as all 3D printing about every other material starts, we need to start with the design of the ceramic or the CAD file. Secondly, the printer actually prints the design layer by layer, of course, additively. After that, after the design is printed, it is left to dry. Then unwanted surface powder can be dusted off the object. We usually do this step manually with the brush. Then the object or the design is placed in an oven to make sure it's dry and fully solidified. Then we place it in what we call a kiln and fire it. Now, firing is a very important process in 3D printing of ceramics. It is used to further improve some properties of the ceramic and further remove the organic binders available. First firing is usually known as biscuit firing. After that, we can glaze the object and refire it at a higher temperature. A third firing can sometimes be done if the ceramic was decorated. Now, the third firing is actually optional, but in every 3D printing of ceramics, we need to have at least 2 firings.
In terms of new developments that the AHRC are funding, and in the last couple of weeks, we've just heard that we've got a large grant for 3D printed self-glazing material based on an ancient Egyptian recipe called faience, known as Egyptian paste. We're really excited about this because we can actually, in theory, take a ceramic material, print it in our 3D printers, take it out of the 3D printer and put it in the kiln and fire it, and it will glaze itself. So the idea is a self-glazing 3D printing material, which is just one firing instead of the 2 or 3 that you would normally do. And the idea that this is an ancient Egyptian recipe initially is really exciting for us.
I've mentioned in the previous slide about what we call glaze. Basically, glaze is an impervious coating of a vitreous substance which has been fused to the ceramic printed object through firing. Now, glaze has many uses. It can be used for coloring, decorating, and waterproofing an item. Now, in this picture, we see a normal ceramic that's been actually manually made, not 3D printed, been glazed. Recently, self-glazing ceramics were printed using 3D printer. Now, this is a very important discovery because this can actually help make 3D printing of ceramics even cheaper due to the lower number of firings required. In this video to the right, we can see Professor Stephen Hoskins talk about self-glazing materials more. In this slide, we're going to discuss and see many of the technologies that are used in 3D printing of ceramics. Firstly, paste extrusion, where a paste extruder deposits layers of ceramics onto a build plate, forming the desired object or design. The first video shows us the basic description of the process of paste extrusion. Secondly, we have powder sintering, where the ceramic is in a powdered form and is sintered layer by layer, and there is also a video showing us that. Thirdly, we have binder jetting, where the 3D printer deposits layers of binding agent upon layers of powder. Lastly, we have photopolymerization, where a light source solidifies a mix of resin and ceramic powder layer after layer. Now, the most common 2 techniques that are used industrially are binder jetting and powder sintering technologies.
In terms of timescale of seeing 3D printed ceramics being commercially available, I think you have to remember that this is a research process, and even though we've worked with Denby, we've got a much further level, it isn't yet really very commercially available. So my guess is the timescale will probably be 15 years before you'd really see easily available product. Having said that, the interest is enormous globally in real materials in 3D printing. And maybe in the short term, it will be used, as Denby are going to use it, as prototyping for trialing things before they make production runs. The future for 3D printed ceramic items outside of tableware is really broad. Areas at the moment we've had interest are things from uses of Ministry of Defence, where things might be armour, medical. A wide variety of people have already come and inquired. We've been surprised by the breadth of people that have come to talk to us about our ability to print ceramics.
Finally, we're going to see the uses of 3D printing in ceramics. Now, here we can also see Professor Hoskins talking about that. To summarize what has been said, in the present days, in the present days, ceramics are usually used in tableware, but it is believed that they have a much bigger potential in the future, because it is believed that they can be used more by ministries of defense in creating armors, as well as medical aspects. Thank you for your time. Hope you found the presentation beneficial, and please do watch the videos. They are really fun. For those who are interested more in this topic, make sure to check those links, especially Science Direct, because it has a very big research on this topic.